Hello everyone, and welcome to the Apps Associates webinar, Deploying High-Performance Database Services with Amazon Aurora. My name is Julian Troke, and I'm the Marketing Director at Apps Associates, and I'm your host today. During the presentation, please ask any questions you may have using the chat window, and we'll answer all the questions that we receive at the end. It's now my pleasure to introduce our speakers. Bill Stewart is the founder and CEO of Petrax, and he'll be sharing his experience as a customer of Amazon Aurora. I'm also joined by Lynn Ferrante, who is in business development for Amazon Web Services, and finally Shidich Kumar, who is the CTO at Apps Associates. This afternoon, Lynn will begin by providing an overview of Amazon Aurora, and then Bill will introduce Petrax and describe how he is using Amazon Aurora today. Then finally, Shidich Kumar will describe and outline the migration best practices. And now I'd like to hand over to our first speaker for this afternoon, which is Lynn Ferrante from Amazon Web Services. Lynn, over to you.
Thank you, Julian. Hi, everyone. This is Lynn here at AWS. And just as an introduction, I've been here at AWS working with Aurora since its announcement at last year's reInvent, then through the preview and GA, and now watching excitedly as many customers are using it in a production environment. So I am going to give you a brief Aurora overview. So we'll talk a little bit about what Aurora is, how it fits into RDS, and what the value proposition and benefits are. So the first thing to understand, which is really important about Aurora, is that it's MySQL compatible. And when we say MySQL compatible, we mean that if you are running MySQL 5.6 and you're using InnoDB, then it's extremely likely that your applications can run without any changes, and your data will just move over. Now, if you're using other storage engines, there's a little bit more work to do. MySQL compatible. We have not changed much of the InnoDB internals. Aurora can be quite fast, and the throughput can be up to 5 times the throughput of standard MySQL. It depends on your application. Your mileage may vary, but we're seeing some fantastic throughput numbers, particularly in highly concurrent environments and on larger instances. Another really exciting thing about Aurora is that it replicates your data across 3 availability zones by default, and you have 6 copies of your data. The way we charge for storage, we don't charge you for 6 copies of data, but it is there as 6 copies of data. We only charge you for 1. But it just makes it that much more available and durable to have 3 availability zones, 6 copies of data, just in case anything goes wrong. You're also able to highly scale with Aurora. We have the Aurora right now on the R3 instance line, so you can go all the way from a small R3 instance up to 32 virtual CPUs, 244 gigabytes of memory. And we have this thing called an Aurora replica, which is different in many ways from a basic MySQL master-slave relationship. Normal MySQL replication is based on bin log replication. Aurora replication is not. That's all in the underlying storage, which was architected specifically for the cloud. So a lot of the things that you would normally be using your upper layer of your database for, we are doing in the underlying storage, and it just makes things so much faster. Amazon Aurora is always within a virtual private cloud. That's how it's set up in RDS. And you can encrypt your data in transit, and very soon you will have encryption at rest. I think we're looking at imminent on that. Also, it's very inexpensive. And if you look at the cost of a commercial database versus Aurora, you'll see that it's about 1/10 the cost while still providing you with the performance and availability of one of those commercial databases. And I just thought I'd give you a sprinkling of some of the customers who are using Aurora now, like Petrax and Expedia, GE, Pacific Gas and Electric. These are all companies that many of them were involved in the Aurora preview and now are looking at or already in production. So what's so special about Aurora? It's part of RDS, the Relational Database Service. So you can create a database in minutes. RDS does the automated patching for you, so you don't have to get involved with that. You can scale up with our push-button scale compute as you go up different instance sizes. We do in Aurora continuous backups to S3. These are automated backups. They're non-blocking, so you always have a backup going on. So it's in the rare event that you have a crash or something happens, with 6 copies of data and these automated continuous backups, you're in fabulous shape. But you can also create user snapshots if you'd like to do that as well, and sometimes that's useful for other reasons. Aurora has automatic failure detection, automatic failover. If you have Aurora instances in other availability zones as part of your Aurora cluster, which is optional, but you can do that, then we will fail over in under a minute approximately. And we have a MariaDB modified connector that can be used for Aurora. If you're using that connector, then failover is usually less than 30 seconds. Aurora is also different than MySQL in that these read replicas, these Aurora read replicas, can be used as failover targets. So you don't have to have separate read replicas and failover targets. So that saves you money right there. And talk about replication lag. Wow, this architecture allows us to really reduce the amount of lag between what would normally be called master and slave in MySQL, I went a little bit too fast there, to a minimum. And I'm going to show you some numbers on that in a subsequent slide. Aurora can scale on the storage side up to 64 terabytes per instance, much larger than any of the other RDS databases. This is available to you. And another fantastic thing about Aurora is that you don't have to pre-allocate space. We will allocate space to your instance as it is needed. That's done automatically. So that's one less thing you have to do. And you pay for only the storage you use. So if you're only using 10 gigabytes, that's all we're going to charge you for, but we will automatically increase as you need it. So let me give you a few numbers here to chew on in these charts. So this is something that we tried because we understood that some MySQL users were having problems as the table count went up in MySQL. So we tried it with Aurora. This is a write-only workload with 1,000 connections, and we went from 10 tables to 10,000 tables, and you see on the vertical scale is thousands of writes per second. The blue bar is Aurora. The other bars are different version flavors of MySQL, and you can see how Aurora really handles write performance as table count increases and can be up to 11 times faster than MySQL. Aurora also has better concurrency, and there's several reasons for this. One of them is a thread pool that we have written specifically for Aurora that handles connections a lot better, shares connections on threads inside the Aurora database. And if you look at Aurora compared to MySQL, you can see that Aurora can be up to 8 times faster under a higher number of concurrent connections. Here we go from 50 up to 5,000. Aurora's the blue, MySQL's the green. In Aurora, caching also improves performance, and we compare this to MySQL because we have noticed that that may not be the same in MySQL. So here we're looking at different read-write ratios of an application. So in other words, 100% read versus maybe 50% read, 50% write, or 100% write. These are all different ways you can describe your application. And if you look at the blue bar, that's Aurora without caching. The tannish bar right next to it is Aurora with caching. And you can see that in the high read and mixed read-write ratios, the caching works really well with Aurora. And here's that replica lag that I was referring to earlier. You can barely see the Aurora bars on this bar graph, so I left the numbers in. And if you look over on the left, you can see as you increase the updates per second from 1,000 to 10,000, how in this instance the read replica, the Aurora read replica lag went from, under 3 milliseconds to maybe under 6 milliseconds, which is really, really low. If you compare it to a MySQL instance, kind of in the same category, then you'll see that you would measure that in seconds, not milliseconds. So that would range right up to 300 seconds when you're doing something like 10,000 updates per second. So if you have read replica lag problems or issues, or you wish your read replicas were a little bit closer to what your master or your primary, we call it a primary in Aurora, is, then this is really, really going to help. And also your Aurora replicas are more available for reading and running reports as well as failover. And the reason why they're more available is because all that replication is going on underneath the, in the storage layer. So it's not that constant load on your read replica, applying those SQL statements or moving that data. And finally, I just wanted to show you some performance results that we ran. Well, this was some time ago. We ran it with the SysBench benchmark, which is the standard, one of the standard MySQL benchmarks, on an R3 8XL with 32 cores and about 244 gigabytes of RAM. And on the left, we have write performance. On the right, we have read performance. And so we're seeing about 107,000 writes per second with 4,000 connections on Aurora. And on the read side, we're seeing, almost 600,000 reads per second on Aurora. So Aurora can be very fast. I think most of our customers would find this kind of performance well within what they needed. And I just wanted to make sure that you had some idea of how Aurora runs. And now I have the privilege of introducing Bill Stewart, who is the founder of PetTracks. And he's going to walk you through his very interesting startup and the work that PetTracks has done with Amazon Web Services, including their recent conversion from MySQL to Aurora. Bill, I'm going to hand it over to you.
Great. Thank you, Lynn. See if I can take over control here. Hi, everyone. As Lynn mentioned, I'm Bill Stewart, and I'm the founder of PetTracks. And today, I'm going to tell you a little bit about our company and the work we've been doing with both Amazon Web Services and Apps Associates. I'll start off with an overview of PetTracks, walk you through our problem that we've been focused on and the solution that we came up with. And I'll finish up with how we've been working with both Amazon and Apps Associates to pull this all together, including, of course, our database conversion from MySQL to Aurora. So as you may have gathered from our name, PetTracks is in the pet industry, which is currently a $60 billion market in the U.S., where we're specifically focused on cats and dogs and their welfare. And when it comes to eating, cats and dogs typically fall into one of two categories. Either they're what we call gobblers, and they eat their food very quickly and are always on the lookout for more food, or they're nibblers, and they tend to eat small amounts of food and graze throughout the day. These two guys you see on the screen, these are my guys, my cats, Ricky and Teddy, and they were the inspiration behind our company. Ricky is the gobbler and Teddy is the nibbler, and while my wife and I are very diligent about feeding them the proper portions and trying to keep Ricky out of Teddy's food, it's very difficult to manage and even more difficult if you're out of the house most of the day. And we started having health issues with Ricky as he became more overweight. So I started to look for some solutions and did some research on this particular issue with pets. This was one of the first sites I found, and I quickly realized that the problem and the opportunity were very big. About 54% of all cats and dogs are overweight in the U.S., and there are, just to give you the numbers, there are 96 million cats and 80 million dogs in the U.S., so it just shows you how big this problem really is. And there are all kinds of risks associated with overweight pets, just like people. These pets are more prone to chronic diseases such as diabetes, arthritis, and various kinds of cancers. And not only does that cause heartache for the pet owners, but the additional annual cost associated with that is anywhere from $500 to $5,000, and in some cases even more than that. And while this website has been up and running for about 12 years now and providing great information to help pet owners, the problem with overweight pets has actually increased during this time. So why, even with all this great information, does the problem continue? Well, first and foremost, most people are out of the home most of the day at jobs or at school. And even with all this great information, if you're not at home to implement the plan, you're probably not going to be successful keeping your pet healthy. Next, most people are in, or most pets are in a family environment where there are multiple caregivers. And as a result, on many occasions, the pets in these homes receive multiple meals, multiple feedings for the same meal by different people in the home. Another issue is that people who work late want to make sure their pets always have food. So they typically leave out a big bowl of food, which is not a good solution and usually ends up in overweight pets. And then the other part of this problem has to do with vet visits and regular checkups. People tend to only bring their pets to the vet when a health issue is more advanced instead of doing regular checkups where they can catch those issues early on. And finally, it's difficult enough keeping your pet healthy if you only have one pet. It's much more difficult in a multi-pet home. And most cats are in multi-pet homes, and many dogs, 1 out of every 2, are in a multi-pet home. So as I thought through the solution and how to solve the problem, the problems I just mentioned, I came up with 3 key requirements. First, the solution had to provide what I call intelligent feeding, and specifically a device or feeder that could automatically feed a pet the proper amount of food at the right time, even in a multi-pet household. The second thing in the solution is it had to be able to track all pet interactions as it related to eating. And I wanted to do this so that we could track trends over time that could be used to determine whether a pet was having health issues so that we could provide proactive information to pet owners. And finally, the solution had to provide intelligent and real-time notifications and alerts to tell pet owners when everything was okay and also to let them know when there might be a problem that needs to be addressed. So with these key requirements in mind, I decided to leverage my technology background and come up with a solution. And since a big part of this problem is that people can't always be home for their pets, I thought this was a perfect case for leveraging the Internet of Things. What you see on the screen here is an alpha version of the PetTrax Intelligent Pet Feeder. And as with any Internet of Things product, it has a central processor, it has memory to store information locally, I/Os to control sensors and other peripherals, and communication so that it can connect to the Internet. The feeder also provides things like food storage so they can operate for up to a week without replenishing food. It can dispense food in 1/8 cup increments. It has temperature and humidity sensors to monitor the environment, a camera foot to take photos and for remote video viewing, motion sensor to detect and log activity around the feeder, retractable food tray to allow and deny access to food, and finally, an RFID reader to determine the identity of the pet attempting to access the feeder. And it does this through either a collar tag or if the pet has a microchip, it does it through the microchip. One of the key differentiators of this product from anything else in the market is that it can be customized through software configuration to work in almost any pet household. All of the automated pet food dispensers on the market today only really work in single pet households, and even in a single pet household, they don't give any detailed information about how your pet is consuming food. They simply dump food into a bowl on a preset schedule, and that's it. Our solution can be configured to work in a single cat or dog home, multi-cat or dog, or even a mixed cat or dog home. So I had a prototype built, set up a server, and had written some basic web services to interact with the physical product. And I also built a basic user interface. And after running the prototype for about 4 months in 8 homes, felt really good about the opportunity and decided to take the plunge and found Petrax. I initially engaged an industrial designer and a hardware designer to take my prototype and build out a consumer physical product, so I had that part of the equation covered. But I also needed to build out a truly scalable computing infrastructure, a set of application services, and a mobile application. And that's where Amazon Web Services and Apps Associates came into play. The question is, why use cloud infrastructure and why Amazon? Well, the choice to use a cloud infrastructure, that was kind of easy for us. As a startup, it's key that we conserve cash. That's one of our top priorities. And unless you're in the business of providing computing resources, it really doesn't make any sense to make the big cash outlays associated with setting up your own infrastructure. So that was an easy decision for us. Now the question is, why Amazon Web Services? Well, for us, number one, Amazon has been doing this for a long time and has a great reputation for providing cloud infrastructure and services. And once we determined exactly what we needed, so all the compute resources and the database and storage and networking and security, once we determined what we needed, we had that up and running in less than a day, which was really, really great for us. Another thing was our monthly costs were extremely low, and the key being that we only had to pay for what we needed. And when you're a startup and you're in development mode and you're not supporting end customers, those needs were really low in terms of these components, and so our costs were really low. And finally, and most important for us, leveraging Amazon enabled us to focus more on the business issues and less on the technology. The other advantage with having Amazon as a partner is the ability to add services and scale the infrastructure as you grow. Amazon provides things like analytics services that we may want to leverage in the future. We want to do a lot of analytics, and having those capabilities with some pre-built services would be great. They also just came out with an Internet of Things set of services, and while we built our own solution for this piece, we may want to leverage that in the future. They have mobile services, application services, again, could be beneficial to us as our company grows. We can look at these offerings instead of having to build them out ourselves from the ground up. These really would provide us with a big benefit. And I really can't stress enough that as a startup, that having that ability to only pay for what you need is really important as we work and grow with Amazon. And then finally, since Amazon is such a big presence, there are many third-party integrators like Apps Associates that you can leverage to help build out and manage your computing infrastructure. So that's why we chose Amazon. We chose Apps Associates as a technology partner for 3 reasons. Number one, I had worked with them in the past and found them to be really highly capable from both technology and business standpoint. 2, they had an Amazon Web Services practice and were very knowledgeable in sizing and configuring those resources. And it's really great having somebody who understands that and can take your requirements and size it properly. And 3rd, they have the ability not only to set up that infrastructure, but to also design and develop the web services in the mobile application. And I was looking for a partner who could pull it all together, and that's exactly what we got from Apps Associates. They sized and deployed our computing infrastructure, which included compute resources, Apache Web Services, Tomcat application services. We initially did the database in MySQL, and then we converted that to Aurora, which is now providing us with a high performance and scalable database at a low cost. And finally, they actually implemented our MQTT messaging services, which gives us a true Internet of Things messaging capability. And as I mentioned, in addition to all of this infrastructure setup, Apps did all of the application development work on our web services, our database, along with our mobile application. Finally, getting to Aurora. So since this webinar is focused on Aurora, I have one slide to speak specifically about that. And the reason I only have one slide is that from my standpoint, the effort to move from MySQL to Aurora was simple. It was a real easy conversion for us. Apps Associates approached me about converting to a more scalable solution on the database side that would help set up Petrax for the future. And at first I was hesitant, I kind of resisted, but they assured me that the cost would be low and the effort would be minimal, so we decided to do it. We set up a separate application stack for Aurora so that we wouldn't interfere with our ongoing development work, and also so that we could run in parallel with our existing setup to confirm everything was working properly. And after our planning phase, the migration only took 7 days. It was really, really fast. And the best part of the process is that we only have to change one line of code, only one line of code, and that was a server-side piece of code that pointed our application services to the new database. None of our devices in the field had to be changed, which is really important because any firmware updates risk taking those devices down, and no changes were required on a mobile application. Those all just worked when we flipped basically that line of code on the server side. Our devices and mobile application just worked, and now with Aurora, we're ready to handle much higher volumes and have better failover and recovery capabilities. Our work with apps and Amazon on the beta solution ran about 6 months and culminated with our beta solution, which includes an intelligent pet feeder with all the electronics and firmware, a cloud infrastructure with compute and web services, application services, much more robust database and messaging, and a mobile application. All of this tied seamlessly together. And we're about to enter our beta testing phase in this solution. So in summary, I believe this was, PetTrax was made possible due to what I call this convergence of forces. First, from a business standpoint, pets being viewed as family members, pet owners, looking for products that can help, and they've come to expect connected and mobile products to keep them connected to their pets. And second, from a technology standpoint, the Internet of Things is exploding. The cost associated with doing these types of solutions is low now, and there are readily available resources and partners like Amazon and Apps Associates to quickly move on these solutions. So with that, I'm going to hand it off to Kshitij Kumar of Apps Associates. He'll walk you through their offerings and some of the technology aspects associated with building out these solutions, including what we did on the Aurora side.
Thank you, Bill. Bill, if you can make me the presenter, I can start with my presentation. So as Bill talked about, we helped PetTrax and several other customers migrate to Aurora from MySQL or Oracle databases. I wanted to share what the experience has been, what we have learned, what some of the best practices are, and also share what tools Amazon Web Services provides to make that migration much more seamless. Before I do that, I wanted to give a quick overview about Apps Associates. So we are a company headquartered right out of Boston, Massachusetts, a global organization with over 650 employees. We started our business in around 2002, and like every other service provider, very focused on on-prem databases applications. But over the last 4 years, we have done significant amount of work with Amazon Web Services and really leveraging those services across our entire portfolio of services, which ranges from infrastructure, databases, business applications, integration, big data analytics, and we leverage Amazon across all of those. So this year, we were awarded the Premier Consulting Partner status from Amazon, which is the highest tier any partner can get to. And not only that, we were also certified as a managed services cloud provider, and there are only 10 partners worldwide who are certified in that particular category. So our relationship with Amazon, with our customers, has been really good. And Aurora is something which has been very key to our portfolio of services. We started to work with the Aurora product development team in the beginning part of the year. So by the time the product came to the market, we had really good exposure and experience with not only the database technology, but also the tools that enable customers to move to that. So the way we have approached Aurora is that there are customers who are running MySQL, and as Lynn talked about and Bill talked about, for MySQL customers, going to Aurora is lift and shift. As Bill said, it's simply a one line of code change. And on the screen here, on the box in the middle, you see that one line of code which I have highlighted to show you only make that one change and your entire application works. So if you are a MySQL customer, the migration to Aurora is something that you should definitely consider because it's a very seamless process. Now, a few things that you have to watch for if you're a MySQL customer is which version of MySQL you are running, what framework you are running. Because it's easiest migration if you're running MySQL version 5.6, and if you're running InnoDB framework, those are the seamless. However, we have had customers who are running a lower version of SQL or a different framework, MyISM or something, and then those can also be converted and migrated over. So the extra effort that would go in those special cases is clearly outweighed by the benefits that customers see from the performance scalability of what Aurora really provides. The second set of customers that we have worked with is customers who are using commercial databases like Oracle or SQL Server. There are various reasons why these customers want to go to Amazon-based database, but the important thing is that not every application which is running on, let's say, Oracle is a good fit to go to an Aurora. So the best example is if you're running an ERP application. You are not going to migrate your ERP application to Aurora. That's not going to happen. So the best use cases are that you may have a custom application doing one-off thing. You may have a web application. So those are the good programs that you can think of migrating to Aurora. Now, the migration from a commercial database to Aurora is not as seamless as what MySQL to Aurora is, for the simple reason that Aurora is like MySQL engine. So every line of code that you write in MySQL would work as it is in Aurora. But when you look at Oracle, your PL/SQL packages, your functions, your table structures, your triggers, they're all specifically written for Oracle. And Aurora is not Oracle. So there is some conversion that you have to go through. But for that conversion, Oracle provides you two utilities, which are at the bottom of the screen. One is a data migration service. So you can enable this utility to migrate your data, set up replication and all. But the second utility, which is a schema migration service, which is going to be your most friendly tool to help you do this code conversion. So I'm going to walk you through some of the screens of how some of this code conversion works. Now, bear in mind that there is no utility out in the market, including this one, which is going to do everything for you. They will get you to a very good amount of good point, like a 50%, 60%, 70%, depending on how your code is, but the rest of it you still have to do yourself. But the majority of the heavy lifting is done by these utilities. But you don't need most of it when you're talking about a MySQL application. If you look at a timeline for a MySQL project, like Bill talked about for Petrax, it took us about 7 days to do the whole work. But on an average, we are looking at a migration of about 4 weeks or less when we are looking at a MySQL application to be converted to Aurora. So I just gave like some blocks of time here as to how are those 4 weeks divided. 4 weeks is not the duration that it takes to migrate. 4 weeks is the entire project, which involves like 2 days of assessment, understanding your requirement. What we find, a lot of customers are running MySQL in a EC2 classic platform, whereas Aurora only runs in VPC. So things like those have to be considered. Your application's integration between EC2 classic to VPC has to be considered. So all of that assessment happens for 2 days. Then for the next 8 days, we do the build. So that 8 days is very consistent what Petrax talked about. It took a week for them. And then we do about 4 days of testing. The testing is something very important where we would like you to do the unit testing. You know your application best. We can run through some scenarios, but we would like you to sign off on the testing. And once the sign off is done, we move into the production phase. We migrate everything over to production. We test it, we support it, and then you are done. So within 4 weeks, it requires all the assessment, the work, the testing, and the migration. And just to point one more thing out, in the middle of the screen here, in the build part, it says migrate from MyISM to InnoDB. So in these 8 days, we can even handle things like converting your storage engine. So if you're running InnoDB, then of course no need, but if not, we can certainly do that too. And it's going to be just handful of days more if we have to migrate your or upgrade your application of MySQL to bring it to the compatible version of 5.6 for Aurora. So very, very, very quick start and very minimal requirement of resources from your end when we are looking at this type of migration. So the approach that we have sort of refined over the months working with customers is, and it's very understandable for us as a partner that you may not just take everything and move it over to Aurora. You may want to try something out, and that's how a lot of people have really gone with it. Try something, and these customers have been MySQL customers and Oracle customers, and once they have liked what they see, then they have planned out subsequent migrations to Aurora to basically take their enterprise in that direction. So here's an approach that we have used. It's a typical waterfall model of define, design, move, develop. But the important thing is that identify an application that you want to use as part of your pilot project here. And a lot of times it's the Oracle customers who are trying to do something like this, less on the MySQL side. But you define what the success criteria are going to be for your pilot project. Identify the application. A lot of times the application is pretty big, so you have to design a slice of the application or a slice of the database that you will migrate. So you see a red line in the middle of the screen. all the tasks above the red line are all Aurora specific, database specific. So you migrate to Aurora, migrate to the database, and then you go and test the backup and recovery. How easy can you access it? So there are actually commands that Aurora provides you, which you can execute, which can fail an instance, which typically is very hard for you to simulate those failover scenarios. But Aurora provides you 2 commands to try that out. So you can try all of those scenarios. And on the application side, okay, in case of, depending on how your application is written, it may or may not need any change. You do your application migration, test it out, and go back to the validation stage, look at your business objectives, look at your success criteria that you define in the business in the beginning of the project. If they are met, you are good, and then you can go forward from there. So with that overview of how the upgrade practices have been, I want to talk about the 2 utilities that Amazon provides, which is your data migration and the schema conversion. So I have some screenshots to give you an idea, and certainly you can look at these utilities and services on the Amazon's web services portal to get a better understanding. So the first one that I want to discuss is the schema conversion service. So the screen that you see here is when we were doing a conversion of an Oracle customer to Aurora. So on the left-hand side, you see Oracle. So these are all the Oracle schemas tables that are available. On the right-hand side, you see Aurora. And in the middle, in this case, it shows you an example of an index. So here's an index which is in Oracle index, but then at the bottom you can see that here's the Amazon Aurora index code for the same index which was in Oracle. So you can look at the code for your Oracle object and see how it got translated to Aurora. You can make changes and you can apply. If you don't want to make changes, you can have Aurora or this utility make all of it for you. So this is a kind of graphical interface that Amazon has developed to help you migrate your code. Now, a lot of times Oracle customers are having several PL SQL packages, procedures that they have. So the first thing that this schema conversion utility does is it essentially scans through your entire code base in Oracle. And it's going to try to analyze that code without actually doing a conversion and tell you that how many of those objects it's able to convert. It thinks it can convert. How many objects it thinks it's going to hit an error. It could be a function which is very specific to Oracle only, which doesn't exist on Aurora. So it's going to tell you that. So here's a summary report which tells you that, okay, in this particular database, how many schemas, how many tables, how many columns are there, how many errors it's encountering, and then how many are critical errors which it just cannot make a change. So it's a high-level summary report that you get. So it gives you a snapshot of how your migration would be. After you have looked at this report, you can go to a detailed report. And the detailed report gives you line by line, object by object, that, okay, I found 5 views having this error. I found 50 tables having this error. Okay, so you get a very granular details that you can get to. And then further, and this is the best part I like about this utility, is that on my left-hand side, I have the report here. And when I click on a particular line item on the report, it opens up the corresponding Oracle package. In this case, it's an Oracle function. And it highlights a line where it's having a problem, or it will have a problem to convert. Okay? So the schema conversion utility or the service from Amazon not only just throws errors at you, you can actually go to the line and say, okay, here's where I'm going to encounter an error. Okay? In some cases, it's able to make a recommendation that, hey, fix it like this. In other cases, you may have to do some work, manual work, to fix those errors. But the fact that it's giving you all of this, right, and it's also converting code for you, is where I was saying on an average, you get about 60–70% of the migration done. The rest of it has to be done by you. So that's a big part which you can use, which Amazon has developed to enable the Oracle customers to go to, or SQL Server customers to go to Aurora. The other utility I want to talk about is called the data conversion service, which is essentially migrating your data and schema. Again, a very graphical interface, very drag and drop based. So here's a screen where I'm essentially setting up my load process. I want to do a full load or incremental load. If my load fails, what should I do? Should I restart? Should I start from beginning? So a lot of options they provide. And you drag and drop, you establish something, and you run the process. And once the process is done, in this case, if you look at the screen here, it shows you I'm moving from Oracle to Aurora. Here are all the tables that moved over. And this is something which we did very recently, like September 21st of this year. What's the table count? What's the row count? How long it took? Migration is done. Replication is set up. And it goes on from there. So a combination of these enables you to adopt Aurora and start leveraging its benefits pretty soon. So in the closing, what I would say is that the best way to really try out a tool is to play with it. So Apps Associate has developed Test Drive Lab, where you can sign up to get a free tier of the service and try this migration out. Okay, so that way you are not incurring any cost. You are getting a true environment to work with. It's sample data which is out there and Oracle data there, and we'll show you how you can move in this Test Drive Lab step by step to go to Aurora from an Oracle database. Okay, and if you like it, you have any more questions, we are certainly there to help. AWS is there to help. And what we have done is to make this migration easy and to just give you how Apps Associate approaches these migrations is that we have really created like a t-shirt size system. Okay, so you can pick and choose what your scenario could be for migration. So you can say that, hey, I have 250 GB of data to migrate. I have 5, 10, or 15 objects to migrate, how many PL SQLs I think in this case, or PL SQL code or packages I might want to rewrite, just to give you an idea. I mean, 5 is a pretty small number, but numbers could be larger. But something which is very easy to understand is something that we can work through you and tell you, okay, this is how long it will take. This is what the migration really looks like. But having done a few of these, considering when the product come out, we have had really good success with this, and of course have had really good relationship with Amazon Web Services, especially from the product development, which is a benefit to you as a customer working with us, that if we run into a unique situation, if we run into a hard spot, we can reach out to the Amazon product development to really get you that help and some advice on how to resolve some of those issues. So hopefully with this presentation, you got an idea of what Lynn spoke in the beginning on what the value proposition is. Lynn talked about the performance and the scalability. The whole storage structure that's for Aurora is very different. That's why you see all those numbers that Lynn was talking about. Bill talked about how Petrex leveraged Aurora, how as a startup company, they were able to move from MySQL to Aurora in a matter of days and really have this company ready for the launch of the product so that they can really be scalable. So with that, if you have any questions, you can post them onto the chat and we can try to answer some of them. If not, we can get back to you.
Well, thank you very much, Chidich, Lynn, and Bill. That was really excellent information that you've shared with everybody today. We have had a few questions that have come in during the session. Chidich, I'll start with you. One question came in quite early, and I think you've addressed quite a bit of it in the slides that you shared at the end here. But the question was, have you seen customers migrate from Oracle on-premises to Aurora? And how difficult is it to do that kind of migration?
So yes, that's most of the customers that we have migrated are on-prem Oracle customers migrating to Aurora, and once again, these customers are those who are running custom applications. Now, as I said, the work involved for migrating an Oracle customer is a little bit more involved. So we typically end up first looking at all the objects you have. We get the count of how many packages, schemas, procedures, packages you have. We have all automated scripts written down to look at those, and then based on that, we can find out, okay, we run this utility to get the idea of that error report. So it gives an idea of what percentage of your code can be migrated. And then it's, as I said, for an Oracle customer, it's a combination of manual effort and automated effort. So it's a combination of that, and looking at the error report that the tool generates, we can come up with an estimate to tell you this is what it would take to migrate you from Oracle to Aurora. So it has been with all the on-prem customers, but if you are a customer who are running Oracle on a cloud, be it Amazon Cloud or someone else's, the process to migrate to Aurora would not change. It will still go through those same steps.
Okay, and I imagine that the answer for SQL Server is very similar.
Yes, it is.
Okay, very good. Thank you. And Lynn, a question came in for you. Early on in the presentation, you shared some statistics and some tests that you have done on Aurora. And one of the questions was, what kind of AWS disk were you using when you did those tests and stats? Maybe you know that perhaps that's something that we need to go and investigate further. But if you know, if you could share that, that would be great.
Sure. So Aurora uses SSDs. That's the only choice. There's no trying to figure out what type of storage is best for you. And that's because that whole storage layer was built separately and cloud architected. And we just thought that was the best way to go with our storage. So it's all SSDs.
Okay, great. Thanks. So we do have another couple of questions, but I think we'll follow up with those individually because we are really at the end of our time today. So last of all, I would like to say thank you very much to everybody who attended. Thank you again to the speakers. If you have any further questions, we'll respond to them directly to you individually, or you can contact us, and all of our contact information is shown on this slide. So this concludes our presentation today. Thank you very much for joining. Goodbye.